We'll now be talking about conditional probability. So this is the symbol for it. So it is P parentheses F line E. And the way that this is read is, well, P is the probability. So it's the probability of F occurring. So it's the probability that F occurs given that E has already occurred. So the probability that F occurs given that E has already occurred. It's called the conditional probability that event F occurs given that E occurs. Yeah, so like literally the same thing we just said. So typically we read this as F given E, F then E, F if E, something like that. So the way we find this is you find the number of ways F occurs in E over the number of ways, not in the total, but in E. So the important thing right now is that E is the new population that we're thinking of, right? It's the new sample. We're not looking at everybody, we're just looking at the ones in E. All right, we'll come back to the second part of the definition in a minute, but let's take a look at this problem. So problem number 2 on the word problems handout. So the results from the survey of 1,017 adult Americans are given below by region. So east, north, south, west, people who believe in God, people who believe in a universal spirit, and people who don't believe in either. So what's the probability that a randomly selected adult who lives in the east believes in God? So who are we actually selecting from? Are we selecting from all Americans? No, we're only selecting from the Americans who live in the east. Can we see that? So we're not selecting from every single American, it's just the ones who live in the east. So these are the only ones we're looking at. So if we add these together, our total, our bottom number, right, our total on the bottom should be 255. So the bottom number will be 255. Now, we want to know the people who live in the east believing in God. Right? So out of the people who are in the east, who are the ones that believe in God? It's this 204 number, right? So 204 is the only ones that believe in God in the east out of all the ones in the east, which is 255. So when we divide that out, we'll get 0.8. And that's our final answer. All right. What's the probability that a randomly selected adult who believes in God lives in the east? So very similar to the previous question, but with the previous question, we were looking at all the adults who live in the east. Now we're looking at all the adults who believe in God. So our population in this case, right, the total number of people that we're looking at are not the people in the east, but it's all the people who believe in God. So it's all of these numbers. So when you add up all of these numbers, all the ones that believe in God, you see that our bottom number is going to be 787. So these are all the people who believe in God. All right. So out of the people who believe in God, who are the ones in the east? Well, once again, we can see that the ones who believe in God living in the east are 204. So the top number is 204 out of 787. When we divide that out, we get about 0.259. That's our final answer. Part C. What's the probability that a Southerner does not believe in God or a universal spirit? So, who are we talking about? Who's our population? Who's the total? This time we're just looking at Southerners, right? So looking at all the people who live in the South, whoops, going to be all of these numbers, right? So when we add up all those numbers, we end up with 254. So 254 will be on the bottom. And then we gotta look at the top. So who are the people who don't believe in either God or a universal spirit? So hopefully you can see that this is 9 people, right? Of the ones who are Southerners, these are the ones who do not believe in either a God or universal spirit. So that would be 9. So if we do 9 divided by 254, we end up with about 0.035. Final answer. Cool, cool, cool. All right, last question. What's the probability that a randomly selected Westerner is from the South? So, who are we looking at? We're not looking at everybody. We're just looking at the Westerners. So all of these people, when you add that up, you'll get 254. Do you? Let me double check that. Yep, 254 again. Yeah, nice. All right, so 254 is on the bottom. So out of all of these Southerners, who are from the South? Well, nobody. These are all the people from the South, right? You can't be from the South and from the West, so there's just 0 people, which is 0. All right. So that's one definition of finding these probabilities. That's probably the easier one of the two. The other one isn't hard, it's just different. So one way to find that is finding the number of ways in E divided by the number F in E, right? So finding the combination. The other way is just finding the probability of each. So you can find the probability of F in E over the probability of E. Because if you notice what happened, right? Essentially, all the ones of F in E, this is all the ones that are F and E, right? We're trying to find the people who believe in God, or the people who lived in the East and believed in God. That was both of them. People who believed in God and lived in the East, that was both of them, right? So we can also just do it with probability. So the probability of F and E divided by the probability of E. So the probability that it is Friday and that a student is absent is 0.03. So since there are 5 days of school in a week, what's the probability that school is on a Friday? So there are 5 days in a week, in a school week, right? What's the probability that a school day is a Friday? Well, one of those days is a Friday out of 5, so that's 0.2. All right. Next, what is the probability that a student is absent given that today is Friday? So we gotta look at the given part, right? We're not looking at all the days of the week, we're just looking at Fridays, right? So on Friday, the probability that someone is absent is 0.2, right? So this is very similar to what we've been doing. On a Friday, the probability that you're absent is 0.2. Now, the probability that you're absent on a Friday is 0.03. So when you divide these out, we end up with 15%, or 0.15. All right, let's do one more. So problem number 3. In 2005, 19.1% of all murder victims were between the ages of 20 and 24 years old. Also in 2005, 16.6% of all murder victims were between 25 or were 25 to 25 20 to 25-year-old males, excuse me. What is the probability that a randomly selected 20 to 24-year-old murder victim in 2005 was male? All right. So again, are we looking at randomly selecting it from anybody? No, we're just looking at the ones from 2000 to 2004 who were murdered. So of all the murder victims between those ages, we see that the probability that they were murdered was 19.1%. So the bottom number is 0.191. Now, the probability that these, of the 20 to 23-year-olds, they were male, right? The 20 to 24-year-old males was 16.6%. So that would be the top number. And when we divide that out, we get about 0.869. And that's it for this lesson. All right, so if you have more questions, I did have more videos online that kind of give some extra examples, so feel free to look at those. As always, if you have any questions, let me know.